Example D. So instead of having only one fraction term like question C, now we happen to have two fraction terms. And further, if you notice in these questions here, the denominator of each of them is happen to be different. So you find out that they doesn't have a common denominator, so the additions between them I cannot do directly, but instead I need to do something to solve this problem here before I can simplify them. So in here, if you notice, both of the denominator is happens to be coincidentally, they are happens to be conjugate to each other. So therefore, in our later calculations, what I will do here is that I will do the calculation in such way like as if like we do cross multiply, where the idea is I try to as if like I consider each of these, I multiply top and bottom corresponding to the other side's denominator. For example, for the first fraction terms here, I'm going to multiply top and bottoms with 1 plus square root of 2 over 1 plus square root of 2. The other side, I multiply 1 minus square root of 2 over 1 minus square root of 2 on both sides. And by the time I do something like this, you happen to find out that at the same time, I actually happens to rationalize each of these terms here. Okay. Before we go on further with the idea of using cross multiply and the calculation like what I explained to you just now, just for your information, in these questions here, we happens to directly do the things that we call cross multiply and then get into one single fractions to do calculations. Is because coincidentally the denominator is happens to be conjugate to each other. If let's say the denominator, they are not conjugate to each other, then I suppose you are more recommended to rationalize each of them separately, and then only you try to go for further calculation, because I believe after you rationalize to have the denominator as a rational number or mostly integers in the denominator, it will easier to proceed further calculation. But once again, since coincidentally in this case here, the denominator for both of these is happens to be the conjugate to each other, therefore we just happens to do cross multiply to have the result as follow. So again, based on the idea of cross multiplier, actually in this case here, what the result you happen to have is that, okay, let me erase the unnecessary trace for the explanation now. How we happen to get the result as I show you. So I consider top and bottom, I multiply with square root 1 plus square root of 2, top and bottom. On this term I highlighted in yellow. What happened you see is that for the numerators, it become 1 plus square root of 2 squared, because top and bottom you multiply with 1 plus square root of 2, which is the same term as what you have in the numerator, so it turned out become square. The denominator, on the other hand, if let's say the other way around, this one I'm going to multiply top and bottom with the denominator 1 minus square root of 2. So what happened on the numerator? 1 minus square root of 2, 1 minus square root of 2, I multiply. You find out that I have 1 minus square root of 2 squared. Denominator, you find out that it happens to be same as what we have for the previous one. Okay. Before we go on further, in order to make our calculation easier in the next part, let us have a quick review or recall on the expansions that we have learned before in our lower form, such that, let's say I have the case of m plus n squared. How we happen to expand for this case here to get the answer quick enough, the result it will be n squared plus 2mn plus n squared. And in here, I would like the arrangement rearranged as m squared plus n squared, the square term side by side, plus 2mn, to proceed for the further calculation. And why I want to do such thing is that, now with this, I may happen to find out that the part I highlighted in yellow, it will turn out as the result as I show you now. So where you find out that the m is referred to the 1, the n is referred to your square root of 2, according to this formula. So as a result, m squared, which is negative 1, n squared, which is square root of 2, 2 times mn, so 2 times 1 times square root of 2, so I have 2 square root of 2. So this is happened to be the result that I got. Then, for the case of 1 minus square root of 2 squared, I need to consider this formula. Just now we do m plus n. Now let us try with the other case, m minus n squared. So what we have learned in the previous, in our secondary level, I find out that I have m squared minus 2mn plus n squared. And once again, I want to group the square term together. This is happen to be the result I have. And once again, if you try to do comparison, your m as if like 1, your n as if like square root of 2. And as the result, I will have the m squared, which is 1, plus with the n squared, square root of 2 squared, minus 2mn, so I have minus 2 square root of 2. Then the last one, the multiplication of conjugate, it shall give me the following result. And just a quick recall, the multiplications of conjugate is actually, we are trying to making use of the idea m minus n multiplied with m plus n in this case here, and the result we have is m squared minus n squared. So now you shall see that, again, your n is 1, your n is square root of 2. So once we're clear about this thing here, the calculation, then we can go for the next part. As a result, let us see what we have if we try to go for the next slide. So the next slide is happen to be just as simple as we just happen to simplify the square root term first. And once again, the one typed in red is just for explanation, how I get this line in black. And therefore, now it's time for us to simplify the term, where if you notice, positive 2 square root of 2 plus with negative 2 square root of 2. So as a result, you find out that the numerators, we don't have the square root term anymore. Whereas the rational number, 1 plus 2 plus with 1 plus 2. So as a result, I will have it as 3 plus 3, and it gives me the answer as 6 on the numerators after I simplify. The denominator, 1 minus 2, it gives me the answer as negative 1. And as a result, I simplify further. This term here is as simple as negative 6 as its final answer.